Okay, so I'm going to work out 2009 number 2 for you. The first thing you can tell is that I've taken all of this first paragraph and I've marked through it. There's nothing that you need to know in it. So do the same thing on your paper if you'd like to. There's some data, blah, blah, blah. It doesn't matter. The second paragraph is where you have all the math numbers that you need to do your conversions. So anyway, you have a cow farm, blah, blah, blah. There's 500 cows. You want to install this methane digester, which is basically going to take methane and make electricity for you, and it's costing you $400,000, and that you also need to know your farm uses 800,000 kilowatt hours of electricity each year, and that it costs 10 cents a kilowatt hour. So, one single cow can produce 3 kilowatt hours of electricity each day. So anyway, A and B are just fact-based questions that you're going to find on the key, and then C is where the math starts. So anyway, C, part 1 says, assuming all the electricity and everything that you need stays the same, find the number of kilowatt hours of electricity that you can make in a year. So, I'm going to go back and look at my data, and, right off the bat, the thing that I see that doesn't really have a buddy that's making electricity for me is cows. So, 500 cows has nothing. All this other, the waste, one cow can make 3 kilowatt hours of electricity, so that's a fraction, one cow over this, and then also, this is each day, so all these things down here are tied to something. The cows is alone. So I'm going to start with cows to find out how much electricity I can make in a year. So, 500 cows. 500 is 5 times 10 to the second. And cows, I'm going to put it over 1. And then I found out that one cow in the data, it told me that one cow can make 3 kilowatt hours of electricity. Now that 3 kilowatt hours of electricity is in a day, and I'm going to take care of that piece of information in a second because they did ask for years. So let's just do this first. All right, I'm going to multiply this out, and I get 5 times 10 to the second, and then that's times just 3. If it bothers you that doesn't have an exponent, put times 10 to the 0, because that's 1 and it doesn't change anything. So anyway, that's obviously 15 times 10 to the second, which is 1.5 times 10 to the third. And, cows canceled, and I'm left with kilowatt hours. Now this, you guys, remember, was what a cow could do in a day. So I get this much electricity each day. All right? Now, there's 365 days in a year. So, if I start here with 365 days over 1, I can use this conversion here, put days on the bottom, 1 day, and I can get my answer for 365 days, which is a year. So, anyway, days cancel. I'm going to multiply, and I'm going to go ahead and put 365 in scientific notation, which is 10 to the second. Anytime anything's 100 or in the hundreds, it's 10 to the second. And then I have 1.5 times 10 to the third. I'm multiplying, so I'm going to go ahead and add my exponents, and I'm going to take care of my units because I don't want to forget about them. And then I'm going to leave me a little blank here, and I'm going to come to the side, and I'm going to go ahead and multiply. So 3.65 times 1.5. So 5 times 5 is 25, and then, carry my 2, 5 times 6 is 30, and then add a 2 is 32, and then that's going to be 15, so 18, and then my 0, and so that one's pretty simple. So I got 5, and then a 7, and a 14, carry my 1, and don't forget when you're doing this, you got to count up your decimals, 1, 2, 3, so I have 5.475 times 10 to the 5th kilowatt hours. And that is the amount of electricity I can make in a year. All right, on part 2 here, I'm going to be asked to, let's look back at the question, I need to know the amount of money that the farmer can save in a year, not including the installation cost. And it told me that I can round to the nearest $1,000. And that's what I was telling you guys earlier. You know, you kept asking me where to round or whatever. It tells you unless it comes out even. So anyway, I, from my cows, have this much free electricity a year. And so if electricity costs 10 cents per kilowatt hour, and I'm getting all this for free, all I have to do is multiply this times 10 cents, and that's going to tell me how much money I'm saving. So let me go ahead and get my beginning here, and this is kilowatt hours, and then the data in the question told me that 1 kilowatt hour, oh, that's bad, I ran into that, sorry. Alright, let me just rewrite that. 5.475 times 10 to the 5th kilowatt hours. Anyway, I'm going to put that over 1, and then the data, 1 kilowatt hour costs 10 cents. 10 cents is 0.1, which is 1 times 10 to the negative first. That's dollars. Kilowatt hours goes away. They wanted money, so I know I'm right because I got dollars in the top right-hand corner. So now I just need to multiply. So 5.475 times 10 to the 5th, and then 1 times 10 to the negative first. And, I'm going to subtract 1 because I'm adding, 5 plus negative 1 and get 4. And then this I just have to multiply, and anything by itself is itself. So remember my units was dollars, and they told me to round to the nearest 1,000. So I don't know exactly how many thousands this is. So let me kind of come down here. It's 10 to the 4th, so 1, 2, 3, 4. So basically I'm dealing with $54,750, which to the nearest 1,000 is just going to be $55,000. $55,000 is the amount of money I'm going to save. All right. In part 3, it asked me to, if you look back at it, it wants to know the time and years that it's going to take to recover the cost of installing the digester. Well, the digester cost me $400,000. So, when it has big numbers like this, it gets confusing. Think about a small number, like, okay, the methane digester costs $10. And, if I save $2 a year, how long is it going to cost, how long is it going to take me to pay that back? Well, if it costs $10 and I'm saving, $2 a year, it's going to take me 5 years to recoup my money. You're dividing 10 by 2. So what I'm going to do is I'm going to divide $400,000 by the amount of money I saved, which is $55,000. So, let me turn my paper over, get some more room. So part 3 is just a simple division problem. $400,000 is 4 times 10 to the 5th. And that's dollars. And then I'm going to divide it by the 55,000 I just found, which is 5.5 times 10 to the 4th. Dollars cancels. And so let's just kind of go ahead and subtract our exponents, and we're going to get 10 to the 1st. And then I'm going to come over here, I'm going to divide. So 4 divided by 5.5. So I have a decimal outside here, so I need to move it once. Then I'm going to move this decimal once. And so 55 won't go into 4, and it won't go into 40, but it will go into 400, let's see, 7 times. So 7 times 5 is 35, and that's a 3, and then it's 35 again. So that's going to give me 38. So I'm going to subtract and get 15. I'm going to drop down my 0, and then I'm going to divide again, and I get 2. So 2 times 5 is 10. Carry my 1. 2 times 5 is 10 again, and that's 11. Now, in the question, it told me that I could round to the nearest number of years, the whole number of years. And so look right here, it's times 10 to the 1st, so that's 7.2 years. So I can stop, basically. And to the nearest whole years, that's your answer, is 0.72. 0.72 times 10 to the first. So that's really 7.2 years. And so to the nearest whole year is 7 years. And that's it for 2009.